Some people say that climate warming is a huge hoax. Why? Because there are counterexamples. For instance, the periodic changes of the sun can lead to uneven heat absorption by the Earth, or changes in the Earth's orbital eccentricity can also cause increases or decreases in heat. The sun is a powerful force in the universe, so how could tiny humans possibly change the forces of the universe? Therefore, climate warming is a false proposition. When you put it that way, it does seem quite reasonable. So what is the truth about climate warming? Will it really lead to catastrophic disasters? When it comes to this topic that determines the fate of humanity, we need to start from the beginning. Let's go back to the spring of 1962, when American biologist Rachel Carson, who was suffering from cancer, was walking along a mountain path. In spring, Carson felt something was off. Why were no birds singing? Where had they gone? What was wrong? Carson stopped, and everything was eerily silent. Too quiet. Where were the birds that usually chirped here? At home, she wrote furiously, naming her book Silent Spring due to the quiet. Where have those birds that used to sing here every year gone? Carson felt a chill run down her spine. After returning home, she began to write furiously, because Carson's spring was so quiet that she decided to name her book Silent Spring. Where have those birds gone? It turns out that synthetic chemical pesticides have killed and driven away these birds. The creatures on Earth have begun to live in a toxic web of chemicals woven by humans, and the culprit is ourselves. Silent Spring caused a sensation as soon as it was published and became one of the best-selling books of the 20th century. 2 years later, Carson died of cancer at the age of 56, but his book remained in people's hearts. The ever-evolving technological capabilities have turned into a double-edged sword, as human activities can actually alter the natural environment, something that was unimaginable in the past. However, climate warming has always been a controversial topic, and many people do not believe it is real. The main arguments against climate warming are based on 2 points of evidence. First, that climate warming is caused by solar activity. The sun is undoubtedly the ruler of our solar system. Its mass accounts for 99.85% of the total mass of the solar system. The total amount of heat radiated by the sun every second is about 3.846 times 10 to the power of 26 joules, while the energy from solar radiation that the Earth receives accounts for only about 0.0045 of the sun's total radiation. That's 4.5 parts per billion. From this perspective, if the sun's temperature increases just a little bit, it can have a huge impact on the Earth. So, does the sun have periodic changes? Of course it does. Sunspots go through a cyclical change every 11 years. The sun goes from a period of high sunspot activity to a low point with fewer sunspots, and then back to a high activity period again in the next 11 years. Are the periodic changes in sunspots the reason for Earth's warming? Scientists have calculated that the change in solar radiation during active periods compared to low periods is only about 0.1%. When you multiply that by the 0.0045 of the sun's total heat, the change in heat is very small. And this amount of heat is insufficient to cause a trend of warming on Earth. So, the changes in sunspot activity have little impact on the Earth's climate. However, the sun is an exceptionally complex and mysterious star, and it can also undergo changes over longer time scales, such as decades to centuries. For example, between the years 1645 and 1715, the activity of sunspots was extremely low, causing the Earth's average temperature to drop by 0.5 to 1 degree Celsius compared to normal periods. The climate has clearly cooled. British astronomer Edward Maunder conducted a detailed study of this phenomenon. So, in the history of climate, it was named after him, becoming known as the Maunder minimum. Do long-term changes in the sun lead to global warming on Earth? The answer is no, they do not. After 1970, scientists used satellites to measure the intensity of solar radiation and found that the intensity of solar activity had not increased in the past half-century. On the contrary, there is a slight downward trend, but the surface temperature of the Earth is continuing to rise rapidly. This shows that global warming is inconsistent with changes in solar activity. In this way, global warming has nothing to do with solar changes. Now that we've ruled out the first hypothesis, let's look at what the second hypothesis against climate warming is. The second hypothesis is changes in the Earth's orbit. The earliest research on this issue was conducted by Serbian astronomer Milankovic. So this theory is also known as the Milankovitch cycles. The changes in the Earth's orbit are quite complex, with three main types of variations. The first is called orbital eccentricity. What is eccentricity? The Earth's orbit around the Sun is not constant. When the orbit is more elliptical, the Earth receives more solar radiation at perihelion and less at aphelion. The second type is called axial tilt. This is the angle of inclination between the Earth's axis of rotation and its orbital plane, which varies between 22.1 degrees and 24.5 degrees. The current Earth's tilt is 23.5 degrees. The greater the tilt, the greater the temperature difference between summer and winter, and the more significant the seasonal climate change. The third is called precession. This refers to the wobble in the direction of the Earth's axis of rotation, which can also be seen as the way the Earth's poles point towards a specific star in the sky. Precession can cause variations in the intensity of the seasons, such as making summers in the northern hemisphere hotter or colder. Now the question arises, is global warming related to these three types of orbital changes? Scientists have calculated that there are two main periods for orbital eccentricity. The primary period is about 100,000 years, and the secondary period is about 400,000 years. The period for axial tilt is approximately 41,000 years, with the worst period being around 23,000 years. In such long climate cycles, changes in climate occur very slowly. So, the changes in the Earth's orbit cannot explain the rapid increase in temperature since the modern Industrial Revolution. From this perspective, the Milankovitch cycles are also not the cause of global warming. So, we've dismissed the two main scientific hypotheses that support the idea that climate warming is a hoax. But simply dismissing them isn't enough to prove that climate warming is real. We also need to find scientific evidence that supports this conclusion. Is there such evidence? In recent decades, many studies have provided relevant evidence. Let me give a few main pieces of evidence, and you can analyze whether these pieces of evidence are reasonable. Ice cores are analyzed to show that there are ice layers in the polar regions of the Earth that have been frozen for millions of years. These layers of ice are built up one on top of the other, and the deeper you go, the older the ice is. Scientists can extract deep ice using ice core drilling machines. These ice cores are essentially time capsules, with each slice of ice preserving a wealth of information from its corresponding era. By analyzing the bubbles in the ice cores and calculating the concentrations of carbon dioxide and methane in those bubbles, we can reconstruct the levels of greenhouse gases in the atmosphere over hundreds of thousands of years. This research method is called obtaining data on ancient natural environments and climate changes. Ice cores. Through calculations, scientists have found that Earth's temperature is highly correlated with the concentration of greenhouse gases. Whenever the concentration of greenhouse gases increases, the temperature also rises. Before the Industrial Revolution, the concentration of carbon dioxide in Earth's atmosphere was about 280 parts per million, but now it has exceeded 420 parts per million. This is the highest level in the past 800,000 years. Ice core analysis provides direct evidence after the Ice Age, clearly revealing the relationship between greenhouse gas concentrations and temperature changes. The second issue is ocean warming. This is more than the atmosphere or land. Since the early 20th century, ocean surface temperature rose by 0.88 degrees. Ocean warming causes water expansion, driving sea level rise. This is far more than the heat absorbed by the atmosphere or land. Scientific data show that the ocean surface temperature has risen by about 0.88 degrees Celsius since the beginning of the 20th century. One very alarming consequence of ocean warming is that it leads to the thermal expansion of water, which is one of the main drivers of rising sea levels. Additionally, warmer seawater erodes polar ice caps, causing glaciers to melt at an accelerated rate. It will also further raise sea levels. Many people don't believe that sea levels are rising. So how is the rise in data obtained? The most precise measuring tool is satellites. In 1992, the United States launched the Topex Poseidon satellite, which was the first satellite specifically designed to monitor sea levels. Subsequently, the Johnson series and Sentinel-6 satellites were launched one after another. These satellites are equipped with an instrument called a radar altimeter, which can send microwave signals to the ocean surface. By measuring the time it takes for the signals to return, the distance between the satellite and sea level can be calculated accurately. In addition to sea level monitoring satellites, there is also a Global Ocean Buoy, ARGO program. ARGO is a global ocean observation network, consisting of tens of thousands of ocean buoys. These buoys can measure the temperature and salinity of the ocean to calculate the thermal expansion of seawater. This allows us to derive data on sea level rise, which falls under direct measurements. There are also data that can indirectly measure changes in sea level. For example, gravity measurement technology also uses satellites to indirectly measure the rise of sea ice by monitoring changes in Earth's gravitational field. Additionally, the well-known Global Positioning System, GPS, can indirectly measure sea level rise by tracking crustal movements. Through these scientific methods, scientists have found that the average sea level rise in the 20th century was 1.3 millimeters per year, totaling a rise of 13 centimeters over 100 years. However, entering the 21st century, the rate of sea level rise has suddenly accelerated to 3.7 millimeters per year. Research on sea level rise has confirmed that ocean warming is an undeniable trend. Some friends might use a graph like the one below to discuss this. From the graph, it looks like there's no difference in sea level between 1880 and 2020. So why claim that sea levels have risen? In fact, these friends are making the mistake of using non-professional data as evidence. From 1880 to 2020, sea levels have risen by over 10 centimeters. This change cannot be detected with the naked eye in a photograph. Just like if a person grows 3 centimeters taller in a year, it would be difficult to tell in a photograph. But measuring with a ruler makes it very clear. This shows that the resolution of images and human perception cannot replace precise scientific measurements. This type of photo does not mean that sea level rise does not exist. The third issue is ocean acidification. Ocean acidification refers to the changes in the acidity levels of seawater, and there are mainly two measurement methods. One is called the glass electrode method, which uses a special pH electrode to measure the concentration of hydrogen ions in seawater. There is also a type called optical pH sensors, which are based on the properties of optical absorption. They calculate the pH value by measuring the absorbance of a dye under different pH conditions. Both of these measuring instruments are equipped on all ocean research vessels and ocean observation stations. pH sensors will also be installed on ARGO's buoys, which are part of the Global Ocean Observation Network mentioned earlier. Why do we need to measure ocean acidity? This is because ocean acidity is closely related to the composition of the atmosphere. About 25% to 30% of the carbon dioxide in the atmosphere is absorbed by the oceans. The absorbed carbon dioxide reacts with seawater to form carbonic acid, which then breaks down into hydrogen ions and bicarbonate ions. This is the reason for the increase in ocean acidity. Scientists have found that the pH of the ocean surface has dropped from about 8.2 to 8.1 since the Industrial Revolution. The change may seem small, but since pH is a logarithmic scale, this means that the acidity of the seawater has increased by about 30%. This value clearly shows that carbon dioxide in the atmosphere has continued to increase. This indicates that the greenhouse effect is also increasing year by year. Ocean acidification can cause significant problems and poses a great threat to the ecological environment. For example, there is a type of phytoplankton called diatoms, which can make up 20% to 40% of the total phytoplankton biomass in some low-nutrient open ocean areas. Ocean acidification weakens the calcification ability of diatoms, which in turn affects the entire marine food chain. With less food available, marine life will significantly decrease, and some species may even face extinction. Another important consequence of ocean acidification is the reduced capacity of the oceans to absorb carbon dioxide. This will cause more carbon dioxide to be trapped in the atmosphere. Fourth, it aligns with climate models. Climate models are mathematical tools based on the laws of physics, chemistry, and biology. They can simulate the operation of the Earth's climate system. Climate models not only can reconstruct past climate changes, but also predict future climate change trends. How accurate are climate models? There's a good example that can answer this question. In 1991, the eruption of Mount Pinatubo in the Philippines was the second largest volcanic eruption on land in the 20th century. The impact of the eruption spread globally, releasing about 20 million tons of sulfur dioxide, which dramatically changed the distribution of greenhouse gases in the atmosphere. Scientists use climate models to calculate that the volcanic eruption would cause the global average temperature to drop by about 0.5 degrees Celsius between 1991 and 1993. The ozone hole over Antarctica would also significantly increase in the short term. After 3 years of observation, the climate change data is highly consistent with the models. As mentioned earlier, the analysis by Bingchen has obtained climate data spanning hundreds of thousands of years, and this data aligns well with climate models. This indicates that, at our current level of scientific understanding, climate models are very accurate, and scientists have a profound understanding of the complexities of the Earth's climate system. The model shows that if human-emitted greenhouse gases were removed, the trend of global temperature changes would stabilize, and might even show a slight cooling trend. The fifth is gas content analysis. The analysis of the gas content in the Earth's atmosphere is mainly carried out through satellites. Satellites use spectrometers to measure the changes in solar infrared radiation after it passes through the atmosphere. Microwave radiation detection technology can also be used to measure the concentration and distribution of carbon dioxide, methane, and water vapor. Some well-known satellites for measuring the atmosphere include NASA's ARS, Atmospheric Infrared Sounder, Europe's Sentinel-5P, and Japan's GOSAT, Greenhouse Gases Observing Satellite. These satellite data indicate that the scope of climate warming is global, with significant warming observed from the tropics to the polar regions. The rate of atmospheric warming has accelerated significantly over the past 150 years due to the increase in gas concentrations, surpassing the range of natural variations. Greenhouse gases mainly come from industrial emissions, agriculture, and deforestation, confirming that climate warming is driven by human activities. These 5 points are the main evidence for global climate warming. In addition to these main pieces of evidence, there are also some indirect pieces of evidence, such as tree rings and fossilized tree rings, which serve as excellent time capsules. In warm and humid years, trees grow faster, resulting in wider rings, while in cold and dry years, the rings are narrower. By analyzing the variations in the width of tree rings, scientists can reconstruct temperature change records spanning hundreds to thousands of years. Can you tell that this is a tree? In addition to tree rings, plant fossils are also important analytical tools. The carbon isotope ratios in plant fossils can reflect changes in atmospheric carbon dioxide concentrations. It can corroborate with the Bingchen analysis. The chemical composition of corals is also an important analytical tool. Corals form a new layer of skeleton each year, similar to tree rings, which allows them to provide climate records on a yearly or even monthly basis. There is a type of boron isotope in coral skeletons, and its variations can confirm the impact of ocean acidification on coral ecosystems. When sea temperatures rise above normal levels by 1 to 2 degrees Celsius for more than a few weeks, corals experience mass mortality, leading to coral bleaching. From 2014 to 2017, the longest global coral bleaching event in history was observed. This affected 98% of the Great Barrier Reef, with 30% to 50% of the corals dying. Coral reefs are extremely important. They are the tropical rainforests of marine biodiversity, housing over 25% of all marine species. If all the corals die, it would lead to the collapse of marine ecosystems. The survival of fish, invertebrates, and marine mammals will all be threatened. There is also an indirect piece of evidence, known as lake sediment records. Lake sediments are formed by the gradual accumulation of particulate matter, chemical sediments, and biological remains in lakes. Similar to tree rings, they also form layered sediment, with each year representing a distinct sediment layer. By analyzing the thickness, composition, and color changes of the mucus layer, we can infer the climate conditions of each year. Scientists have found through the analysis of sediment from lakes such as Lake Baikal, the Great Lakes in the United States, and Lake Tanganyika in Africa, that the organic carbon content in these large lakes has significantly increased since the 20th century. This indicates that the rate of modern climate warming is faster than at any time in the past 10,000 years. The examples mentioned earlier confirm that climate warming is not a hoax. It is a real phenomenon. But why do many people not believe in climate warming? There are probably a few reasons for this. First, there is a misunderstanding or misinterpretation of science. Climate science is a complex field, and many people do not understand the basic concepts of the greenhouse effect and global warming, which makes it difficult for them to accept the related theories. Additionally, there are misunderstandings about individual extreme events. For example, some people believe that their region is colder than before, which seems to contradict global warming. This is a mistake of generalizing from specific instances. For instance, Florida, in the United States, experienced a once-in-a-century snowfall. People might think, this means the world is getting colder, right? The reality is that the ice caps in the Arctic are melting at an accelerated rate, which weakens the stability of the polar vortex. The cold air from the poles spreads more easily southward, reaching as far as Florida. This isn't global cooling. It's actually a response to global warming. Economic and political interests exist. Reducing oil and coal use affects these industries, which may oppose. Some fear climate action expands government power, leading to denial. Media spreads skepticism and misinformation, causing doubt. Some people link climate intelligence to politics, thinking addressing climate issues expands government power, rejecting climate warming. Media and information spread play a role. Many online articles promote climate skepticism and misleading info from pseudoscientists. This info can lead people to doubt climate science. Many individuals show selective bias, accepting only info aligning with their views, and misleading information from pseudoscientists that can easily make people doubt climate science. Additionally, many people exhibit selective bias, tending to only accept information that aligns with their own views, ignoring the mainstream consensus in the scientific community. Fourth, psychological and cultural factors come into play. The consequences of global warming can be frightening, and some people choose to reject the reality to avoid that fear. Additionally, many people are more focused on immediate economic benefits and their current lifestyles. What they care about is short-term benefits. What about the future? They aren't very concerned. That the data on climate warming is quite alarming. Scientists have reported that from 1850 to 2024, the global average surface temperature has risen by about 1.55 degrees Celsius, and the average ocean temperature has increased by about 1.1 degrees Celsius. In 2024, over 100 countries around the world experienced the hottest year on record. It's not just the satellite records of the Earth's surface that show this. From 1979 to 2024, the average temperature in the troposphere has also risen by 1.2 degrees Celsius, and the temperature of the Earth's atmosphere continues to increase. It seems that the Earth is warming in all aspects, whether it's the oceans or the atmosphere. Climate warming is an undeniable fact, and it could lead to extreme weather, ecosystem collapse, food and water resource crises, intensified social conflicts, and significant economic losses. Climate warming is no longer a distant threat. It is a global crisis that is currently happening. Climate warming is not caused by one person. It is a result of all humanity's actions, and it requires a collective effort to face this challenge. This means we must firmly implement the Paris Agreement and strive to keep global warming below 2 degrees Celsius. There is only one Earth, our shared home, that protects all of humanity. This is not just a slogan, it's a matter of life and death. Alright, that's it for today's show. Don't forget to follow Lau Ming's channel, and we'll chat again in the next episode.